Hello, today we will be studying redox reactions, which can be abbreviated as follows. By the initial letter of each of these words. In the previous lesson, we discovered the identities and connections of these reactions. These reactions involve the transfer of electrons between a compound referred to as a reducing agent and another compound known as an oxidizing agent. The oxidizer accepts the transferred electrons. Now let's examine such a process that takes place between the two compounds, between a metal and aluminum. Aluminum is a solid that will be placed in a solution of copper chloride, which is an aqueous solution of cuprum chloro 2. Why is this reaction possible? If we look at the activity series of metals, aluminum can displace copper because it is stronger than copper. Then aluminum takes the place of copper and becomes a salt. Aluminum chloro 3. Such a substance will be in solution. So we'll show that it's a solution. So what will happen to the copper? The copper will settle out as a red precipitate because copper has that color. Let's look at this process from the position of a redox reaction. In order to make sense of it, let's put the charges. Simple substances have a charge of 0. Cuprum chloro 2 has a minus here, and copper has 2 pluses. In aluminum chlorine 3, chlorine has a minus, and aluminum has 3 pluses. The simple substance element copper has a charge of 0. So what happened? Aluminum goes from 0 charge to aluminum 3 plus. So it loses electrons. Write this down in the form of writing aluminum 3 plus and plus 3 electrons. The electrons that aluminum loses are not commonly written in the left-hand side, and the recording form would look like this. What does copper do at this time? Copper from a charge of 2 plus will take 2 electrons and change to copper with 0 charge. Then in the electron balance, we have the numbers taken out by aluminum 3 and copper 2. Then, in order to balance the number of electrons given and received, they are swapped, and these numbers are obtained by rearranging them. Opposite aluminum is a 2, opposite copper is a 3. Now, what are these processes called? Aluminum loses electrons. It's an oxidation process. Let's sign it. And aluminum itself will be called, respectively, the reducing agent. It's called the reducing agent. Alright, what then would be considered as our copper? Copper refers to the process known as reduction. And this element itself is called an oxidizer. That would be oxidizer. Good. Now how do we arrange the numbers we've got? These are called the basic coefficients. We have a 2 in the aluminum row, so we'll put that 2 in front of aluminum. I pay your attention, the first coefficients are put in front of the 0 charge. The 3 will go to copper with 0 charge. There's a rule of arrangement in this case. Now aluminum on the left is 2. It should be 2 on the right as well. So we'll put the coefficient 2 in front of the aluminum chlorine 3 formula. Well, copper on the left is 1 and on the right is 3. Then we'll put a 3 in front of the cube chlorine 2. Let's check the chlorine. Chlorine on the left is 6 and on the right is 6. This reaction is irreversible. Once again, recall that the entry that we've shown here in these two interactions, these are called half reactions. And they involve respectively, two processes. These are the process of giving electrons, the process of accepting electrons. Now we can break this process down from the position of what happens if we dissect each of these substances. Then we get 2 aluminum, a solid. The chlorine 2 cuprum, this would be a substance dissociate into 3 cuprums, charge 2 plus, and this would be an aqueous solution. Plus, respectively, 6 chlorine ions, and they will also be aqueous. These ions are in solution. Chloro 3 aluminum will also dissociate into 2 aluminum 3 plus, which are in aqueous solution. And the chlorine ions will be respectively 6 chlorine minus, and they'll be aqueous. And also copper, which will have in the solid state with a charge of 0. I call your attention to the fact that we have similar such ions called contractible ions. And we can reduce these ions on the left and on the right, and then we're left with 2 aluminum with a 0 charge solid, plus 3 copper ions with a charge of 2 plus in solution, and on the right side we're left with 2 aluminum 3 plus as ions in aqueous solution, and three copper, which has a 0 charge, and it will be in a solid state. Thus, redox reactions, as you can see, are complex processes in which coefficients have to be selected, and coefficients are selected through a special method. This method is quite difficult, but we will definitely figure it out, learn how to make even more complex examples. But the most important goal that faced our lesson was to work out once again what processes are called oxidation reduction, how we recognize these processes from our half reactions that we recorded, what are the additional elements that we showed as an oxidizer and a reducing agent, and we finished this scheme with this process that shows what exactly can you reduce in the end, and we got the so-called reduced ionic equation, but this is the equation of the redox reaction. Look at how difficult these examples are. But I hope it has become clear to you, and in the next lessons we will continue to study this topic because it is very difficult and is usually included in exams, so you need to figure it out. Goodbye.